Hello everyone, my name is Ágos Tondány, and right now we'll take a quick look into the Docker, and I will introduce you to the Docker fundamentals, what Docker is, what and how it differs from traditional virtual machines and so on. Right after that we will install Docker, and we will work with Docker images and starting the Docker containers, and we'll work with them. Take a quick look at how to work with persistent storage for Docker. You will know why do you know this. And after that, we will provide network connection to the containers. So, how Docker differs from the traditional virtual machine and virtualization? If you remember and know the virtualization as usual, you know that you have your infrastructure, the storage, the computer and so on, and you have a host operating system, Linux or Windows or anything else. You have a hypervisor just like Hyper-V, VMware, KeyVM and so on, and you install the virtual machines. And the virtualization layer will provide motherboard, virtualized motherboard, CPU, memory and so on to the computer. And you have to install the guest OSs, just like Linux, Windows, and so on. And you will install the binaries, the libraries, the database server, and so on. And after that, you will install the application you want to use. So it's a bit complicated sometimes, and you can use Chef or Puppet or anything else to automate these procedures. But it has its own overhead. So what is the overhead? In a traditional virtualization, the operating system emulates, and the hypervisor emulates the whole machine, a virtual machine, to the guest OS. So you will have a little overhead, and the density of the operating systems is limited. Number of virtual machines are limited. So what Docker is? Docker differs from the traditional virtual machine systems, that it has single operating system, so it's Linux or Windows, but Docker right now only operates on Linux, and you have the Docker engine, and you don't have to install guest operating systems, and you don't have to provide virtualized motherboard, CPU, and so on. So this is what we call container virtualization, because these are containers. And what are in the containers? The containers are the libraries, binaries, just like the SQL server, just like MySQL, PostgreSQL, and so on, and your own application. It has the advantage that you can achieve much more density on a single storage, on a single host, and it boots much faster because you don't have to emulate the whole hardware, just like with the traditional virtualization. But it has its own drawback. The drawback is that you use the same operating system and the same kernel. So you are not able to run Windows applications under Docker engine. So right now with Docker, you are limited to the Linux system and the Linux applications. But it's not so big limitations because it gives you much more advantage over the traditional virtualization in the case of density. And Docker provides a special format which is very good for you if you are a developer or you are a system engineer, because you don't have to install your own operating system under the virtual machine. You just have to deploy this container. This container has a specification, the Docker specification, and if you use a Docker image, because we work with images, and the Docker engine will just extract it, just like the traditional, just like the RAR or a zip application extracts the files from a zip file or other compressed archives. You just pull or deploy a Docker container, and the Docker engine will take care of that. And so what does it mean? You can package your applications. Let's say that's your application, and where Docker engine is supported, you are able to run it. So where Docker Engine is supported. And Docker Engine is supported on your own system if you install it, but it's supported on Azure, Amazon, and Google, and lots of other cloud vendors and cloud providers. So how Docker work with images? As you know, we have the kernel, which is the same for all the applications, and we have a bootfs. Bootfs is a feature that we use to provide a virtual file system to the Docker images. And why we say images? Because in a Docker architecture, you always have a base image to provide better storage, and you have other layers. So these images are put together by the Docker using a union file system. So you have the base image, and you have the binaries and other images, and we call them layers. So it's a multi-layer image, and it has its base image and its other parts. And if you have this base image, it has the advantage that you can use much less space, because if 100 container uses this base image, you only have to store it once. So instead, what you have to know about the traditional virtualization, let's say you have a base Debian virtual machine and it consumes 1 gigabyte. If you run 100 Debian machines, it will consume at least 100 gigabyte storage from your system. But in the Docker architecture, because every container uses the same base image, and these containers are read-only, we'll talk about that a bit later, it will consume only 1 gigabyte. So if the Debian base image is 1 gigabyte and 100 container use the base image, you will only have to store 1 gigabyte. So this is a big advantage because the storage is always expensive. And if you have to have, let's say, MH, or you have to have an Apache, the Docker stores them in different images and put these images on top of each other, and these are different layers, and it will just union them, and these will form a container, because this part, the stored images part, are the Docker images, and this part is a read-only, so you are not able to write anything into the file system. But on top of everything, the Docker will provide you with a read-writable layer. And this is where you change your configuration. But you have to be aware that these containers are ephemeral. They are not persistent. So this layer, this writable layer, it's not persistent. You have to use volumes or writable volumes for that, and we will use them later. But what you have to know is how a container formed. So the container formed using the images, and the Docker puts these images or image layers on top of each other and starts the container and put a read-writable layer on top of that. But this is ephemeral as well. Okay, so let's install Docker on your system. Our system is a standard simple Ubuntu. And where you find Docker? If you go to the docker.com, you can download and install it from source or from binaries, or you can use the package manager from Ubuntu. But just take a quick look at what we have in the latest Ubuntu system. So let's search for docker.io. This is the name of the package under Ubuntu. So if you want to stick with the distribution provided version, you have to look for that package under Ubuntu, because in CentOS or OpenSUSE and so on, maybe the name of the package differs from docker.io. But in Ubuntu, it's docker.io. So press enter. Okay. We have it. Docker.io Linux container. Runtime. And show the package. Type in apt-cache show docker.io and look for the version. The version in Ubuntu, it's 1.5.0, but the latest, as you see, it's 1.7, and as the pace in the changes in Docker, it's very fast, so everything's changing very fast. It's better to use the latest Docker. So how to install it on any Linux system? The Docker guys helped us because they created a script what you can reach at https://get.docker.com. Go for it. And as you see, it's a simple shell script, and it will look for your distribution and install the latest packages. So what Docker provides you is the binary images, the latest images for your Linux system. And they have a little help here. So how to use it? Okay, we can copy and paste this command, use the wget and install it. Okay, and we don't write out this file into a file in the file system, but we put it on the pipe and provide it to the shell. Okay, go for it. First it imports their key, so they just sign their packages. So you can make sure that nobody touched the images, so no hacker or any other intruder were able to modify the package. After that, it updates the package list and look for the packages. And it automatically installs the required packages from their repository and from the Ubuntu repository. Okay, and it gives you some instructions that if you want to modify the Docker configuration or you want to provide a user with administrative privileges under Docker, you can use this command. So if you want to provide the Duckademy user with Docker administrative privileges, I have to put the Duckademy user into the Docker group. This is what it means. Okay, and just type in ID Duckademy, and you can see that the Duckademy user right now part of the Docker group. So I can do anything without root privileges with Docker. I can just run Docker, run containers, start containers, stop containers, and so on. Okay. So what's next? Next we will search for the images and pull the images, but first we'll take a quick look at how this image storage works under Docker. Okay, so as you can see, this figure comes from the docker.com as well. So this is a very official figure. And we will use these commands to pull and run the Docker containers. And as we talk about the Docker images, where do you find the images? How you get the images? You can find them on registries. So the registries are the storage for all the images, which forms a container, and You can use the Docker own registry at the Docker Hub. They provide it to you for free, and this registry is public. You can set up your own private registry, or you can buy a private registry from Docker as well. But all the images comes from a Docker registry. So these are the images. And when you want to run a container, first you have to pull the images which forms the container, or you can pull it before you run the container. But if you don't pull the images previously, when you want to run a container and a container knows what images it has to download, the Docker subsystem will get the images from the registry. Okay? And the images what you download from the registry are stored on your local system, on your local file system, on your local server. This is your Docker host, your Docker server. And you store the images here. And whenever you just want to form and run a container, you will work with the local images. And you can update them, and you can just pull from time to time. Later, you can just delete the images from your Docker host, and you can just download it again from the registry. So this is how it works, that the Docker host only stores the required images to form your containers. If you don't want to run that container again, let's say you just stop and delete this container, and you don't want to store the images, you can just erase them from your file system as well. Okay, where you find the public Docker images and the registry, there's a site called hub.docker.com, and this is where you can sign up and you can store your own images later, and you can use it for free as long as it's public. And we can look for the images and search the registry for a specific application. So look for WordPress, and you can see there are lots of Docker images and lots of Docker containers for WordPress, and you can see how many people downloaded it and how many stars it have. This is just like how many marked it as a favorite. And you can see here when was the last time when it has been updated. So you can bet that the WordPress from Docker, it's very fresh. But as you can see, lots of other guys packaging Docker containers using the WordPress. And you can just, for MySQL, you can see the Docker guys package the MySQL as well, but there is MySQL container from the MySQL guys as well. So you can just choose what you want to download. Okay, it says it's automated build. If you use GitHub or Bitbucket and you store your own code there, you can build app containers from it as well. So you can automate the build process. So in a training, we can take a quick look at it and how to use it. But right now, we just want to use the images. You don't have to download the container and the images what the container use from the website. We can download it from our Ubuntu server. Okay, how we look for the images? We will use the Docker command, and the Docker has a search subcommand. Let's say Docker search MySQL. Okay, I will make it a bit bigger. And you can see the 10 or the 20 most popular Docker containers. And who built it? If you don't see any other tag here, so it's not MySQL or anybody else, so it only stands here the MySQL for a container, it means that the Docker guys packaged it. So you can just search for the base image. Let's say Docker search Ubuntu. And you can see there are Ubuntu images. Okay. So, how to download an image? Let's say Docker pull Ubuntu. And it will contact the registry at the Docker, and it will download several images. As you can see, these are the layers. These are different images, which forms a container when you start a container. So these are the layers. Okay, when the Docker pulls the image, it will extract the image layers, and the image you are pulling has been verified. So what does it mean? That the system verified that they come from a secure source and nobody touched it. Okay, as you can see, it uses a digest as well, and the version you pulled is the latest. So if you just pull anything, just like the CentOS or anything else, always look for the latest. So what I issue the command, the docker pull Ubuntu, if I write with a semicolon latest as well, that means the same. This called the image tag or the container tag. So this is a tag, and they tagged it with the latest. So right now, as you can see, it's already done. It's image up to date. Because without any other tag, the Docker always pulls the latest images. But what if you want to download a specific version? Let's say the latest Ubuntu, I know this is the 15.04 version, but I want a long-term support version in my container, and this is the 14.04. I have to use the tag. Okay, just look what happens right now. Okay, some layers already existed. Some images existed, but some are very new. So right now I have the latest version from Ubuntu and the latest long-term support version from Ubuntu. Okay, what images I have? Just I will clear the screen. So what images I have? Issue the Docker images command. Okay, and I can see that I have Ubuntu from the repository, and the text says these are the latest. Okay, it's created. Okay, it's almost the same. It has to have some differences. Okay, how do I start an image or a container? Let's run some Docker containers. Docker has a subcommand called run, and you have to provide some options to it. First, we will provide it with the -t. The T means it will attach a pseudo terminal, so you can attach to it and you will have a console just like that. And we'll provide I, which means interactive. So it will keep the standard input open, the standard input file descriptor open. And even if you detach from the container, you will see what does it mean. And okay, start a container, Ubuntu, and it will use the Ubuntu latest, or you can use a tag. So we will run Ubuntu 14.04, and I want to use a shell inside it, and I want to get inside the container. Okay, this is how I start a container and go inside the container in one step. Okay, as you can see, the hostname changed. This is the name of the container, or the hostname, the short hostname. This is just like a UUID or anything else. It has been generated, and I'm the root user. Okay, so let's say, where am I and who am I? Okay, I'm the root user here as well, and if I just type ls space / I can see all the subdirectories, and let's say I want to start a top command. Well, as you can see, I only have two processes. First is the bash, the second is the top, what I just started. Okay, because it runs inside the container. Right now I'm in a container, and if you want to quit the container without stopping it, you have to press the Ctrl and the P and the Q after that. So this sequence, Ctrl plus P, and hold down the Ctrl and press the Q again, and you will get back to the host computer. And let's say, look for the top process, and look for the ID. Okay, here's the ID. So this is the top application, and you can see the process ID is 12,142. But I only run this top inside the container, and no other top runs on the system. And as you can see, it differs from the process ID inside the container, because inside the container the applications have a different process ID namespace, so they cannot mess up with the host system or with other containers. They are isolated from each other using it's called the namespaces. Okay, and how can I go back? I can attach to a container, but I don't know what the name of the container. Okay, I know because I had somewhere here, but it's generated. But if you want to see what Docker containers running on your system, issue the command docker ps and press enter. Okay, as you can see, it has a container ID. This is the hostname. It tells you what image the container uses, what command it runs, when it has been created, and its status. Okay, it's up 3 minutes, and so on. And it has specific name. If you don't name your container, I could start a container providing it with an arbitrary name, but if you don't attach a name to the container, the Docker will generate a name for that container. So it's always an adjacent and a name after that. So I can attach to it with the subcommand attach, docker attach, and I can use the container ID or the name. It doesn't matter which one. Okay, I will attach to ecstatic Hoover. Funny. Okay, and as you can see, I'm again here using the top. I quit from the top and press Ctrl+D, so I exited. But when you exit this way from an interactive terminal, the Docker container runs no more, so it stops the container. And all the changes what you have been made on the read-write layer has been lost, but the container itself is intact and it's here. And you can list all the containers, even the ones which are not running, the docker ps space -a. Okay, and I can just start ecstatic Hoover again. Okay, and it has been started in the background. We have another subcommand called docker top. Okay, and oops, the docker top tells me what kind of applications runs inside the container. And if I issue the command docker top ecstatic Hoover, I can see it's okay, bean bash has been started, because that was the command how I started the container. If you remember, I created it with the bean bash option to run it as the first command. And right now it's running again. Okay, how can you just stop the container? It's very easy. Docker stop, and right now I will use the container ID. Okay, and it has been stopped. Okay, what's on the system? What you have to know more. There's a directory under var lib docker. Just change the directory, var lib docker. And if you list the contents, you can see here a containers subdirectory. Go there and list. Okay, you know, this is the long name of the container. As you can see, the 5BDC and so on is the same. 5BDC88 and so on. But this is the long ID. Change that. If you list this directory, you can see there are some configuration files here, just like the host name. Cat it. As you see, this is the short ID, the so-called short ID. It has its own resolve conf, host, and these are the same files what you can find in a running container. And it has its all configuration in a JSON format. So this is where you find your containers. Okay, and as you can see, no binary images are here. So because if I start multiply containers using the same base image, they will only differ from this configuration and the ephemeral read-writable layer. So this is why a Docker container doesn't consume so much space as a traditional virtual image. Okay, start again a container. Just change back to my home directory. Okay, cd. And run another version. You can see what happens. If I don't pull the image previously and just issue the docker run command, let's say I want a version 12.40 and start it. Oh, and I just almost forgot to issue the T and I options to that. Look what's happening. It's unable to find image locally and it will start pull all the layers for that, and after that it will start the container, and I will have another image, and it's all happened automatically. I don't have to pull it before. So you have your own private registry and lots of host computers, lots of Docker hosts, and you want to start up a container. You don't have to manually or just some managed way to copy the images to the host, because the host will download all the required layers and images to form the new container. Okay, look whether it's running already. Oh, yeah, it's not. I'm inside the container as well. So I tried to issue the Docker PS, but as I just told you before, it just pulls all the images, creates it, and just put me inside the container. As you see, the so-called short name, it's a different one. And if I just quit, it will stop the container as well. I just clear the screen. Okay, and if I want to run a Docker container without attaching it immediately, but later I will want to attach to it, I can use the -d, which means it starts the container in detached mode, but I still have to use the pseudo terminal option and the interactive option, because if I don't give these options to the container, later I will not be able to log in interactively. And you can name your container. Let's say it's duck. So instead of the random name, I will provide one to that. And let's say I want to run the Ubuntu and the version 14.04 and start it in bash. Okay, and it started. And if I issue the command docker ps, as you can see right now, the name is duck and not a random name. Okay, I just stop it with its name. Okay, and it's working. So, as you know, the read-write layer inside the container is ephemeral. So everything is lost when you just log in or you just stop the container. So how can I use a persistent storage? You can give a volume to a container and it will be a persistent storage for that. Okay, so let's say docker run -ty and issue the -v, just like volume. And you have to give a mount point, and the Docker will create this mount point inside the container, and it will be writable. And when you stop the container, the contents will still be there. Let's say you want to store everything in data, /data. Let's name it. But right now I have to name it duck2, because if I just type in only duck, the Docker will refuse to create it because it's already exists. I could start it with the V option, but when I create a new container, I have to give a new name to this. And I will start Ubuntu 14.04 and be in bash. Okay, right now I'm inside this container. Just list the subdirectory and there's a data. So on a normal Linux system, you will not see a data subdirectory under the root directory. Change here. go to the data subdirectory and just create some files. Just let's say touch A, touch B, touch C, touch 1, 2, and touch 3. Okay, and press Ctrl P and Q. Okay, right now I'm at the host computer. Change to the Docker var libdocker subdirectory, and there is a volumes subdirectory here. Go to that subdirectory and list it, and as you can see right now, here's a directory with a very long name. Go to this directory and list the contents. As you can see, underline data is here, just like our mount point, but instead of the slash, it's underline, and list. And as you can see, the file names are the same what I have been created. So go back and attach to duck2. Attach to duck2. Okay. Just remove one file. Let's remove the C and stop the container. You know, we can just stop the container when we just quit. Just to be sure, issue docker ps, and as you can see, no images are running, so no container is active. And if you list the same directory, you can see the C is no more here, but I have all the files in this subdirectory. So this is how you create a persistent storage automatically on a Docker host. So this is an auto-generated directory under the var libdocker volumes. But what if you want to attach a specific directory from the host to your container? Okay, just go back to my home directory and let's say create a subdirectory under the srv. Let's say it's a duck2. And how can I attach this directory to my container? I will create another container to demonstrate it. Docker run -ti -v, and I have to provide first the subdirectory from the host what I want to attach to the container. Okay, just use colon, and let's say I want to use data again, but I want to name this container to duck3 and use the same Ubuntu 14.04 image and create a bin bash comment here. Okay, let's say whether I have the data. Yes, I have, but nothing inside it. Change it to it. Create some files, just like before. Okay, I have 3 files here, and exit. Okay, and let's see what's inside this directory. Okay, it's duck2, but I just named my image to duck3, but okay. This can be misleading, but it's not so big problem. Okay, and all those 3 files what I have been created here. Until this moment, we just started containers without any network connection. Right now we have persistent storage and so on. But how do you provide a network connection to your container? If you want to expose a port, this is how we call it, expose a port, to open up a port in a container, and the container will be able to communicate through this port. Just download another image. Let's say docker run -ti and use the MySQL image, and just start it in the detached mode and issue the command option -p and a port 3306, because this is the default MySQL port. Okay. Docker will look for the latest image at the Docker hub. Just download it, extract it, start it, and after that we'll take a quick look whether the port is open or not. Okay, and after everything has been downloaded, the Docker just started a new container, and this is the long name of the container, and issue the docker ps command. Oops, it's not running. Maybe we lack something. Okay, started with a command bin bash. Okay, so after that I started the MySQL image with a bin bash, and after that it has been started, and as you can see, the MySQL port has been opened. And if I just type in the IP tables -L and -T for the table net, for the network address translation, I can see that the local port, this local port 32,769, will be forwarded to the MySQL port of some IP, and this IP is the IP of my MySQL container. Okay, but no single application will just look for MySQL on that port. So I have to list the containers. Okay, and it's Stoic Einstein. I have to stop it. Oh. Okay. And I want to make sure that the same port is forwarded to my container, what I just want to expose. So go back to this command, docker run detach, and open up the local port 3306 and map it to the container port 3306. This is how I open up a specific port on the host system and forward it to the container. Okay. Issue the docker ps command. And as you can see, everything which comes inside the host to the port 3306 will be forwarded inside the container to the same port. And right now it's Stoic Stalin, not Stoic Einstein. Okay, and what was that IP address? This is the internal IP address of my container, and how the other computers are able to reach that IP address. This is because if I just list all the interfaces on my system with that command, there is a bridge a Docker Zero bridge. And as you know, a bridge will provide network to the virtual machines, just in a case of KVM, so it's almost the same. You can just open up specific IP address and port connection. So I could just, let's say, if I have this IP address, I could just, let's say, I just wanna open up the MySQL port only on that IP address. So if you have lots of IP addresses, you can just expose the ports to the containers, and everybody will be able to reach that computer. So this is how I just expose a port, and this is how Docker networking works. That every container which has networking connections attached to the Docker bridge interface, and there will be a virtual network controller on the host computer as well. It's auto-generated, and its name is auto-generating, and this is a point-to-point connection. So in the host computer you will have this interface which has been attached to the Docker Zero bridge, and if I attach to my MySQL server, and I just type in IP addr show, I can see I have a general Ethernet connection or an Ethernet interface, and this Ethernet interface is linked to this one outside interface linked to the bridge. So this is how the computers outside my host reaches the containers and form a network connection with the containers. The connections comes inside, and Docker bridge will forward a connection to the virtual interface, and it will just forward everything inside the container to the internal Ethernet interface. So that was all how the networking works in the Docker, and this is just the basic because we have lots of other options, but we will just take a quick look at it another time. Goodbye.